Welcome. Quite nice to see the room so packed with developers, I suppose. Or at least, are you a developer? Can I see a show of hands? Okay, nice. I'm not. Uh, so I was quite anxious for today to talk to so many specialists in Java while I'm still a noob. But today we are going to talk about pwning your Java service because I'm good at one thing, pwning your Java service. But before we start, I just want to see a raise of hands who has been familiar or had to work due to the log4j vulnerability a couple of years ago. Not all of you. A bit more recent, the Spring for Shell vulnerability. Whole lot less. Who uses Spring? Whole lot more. So that amazes me because there was a vulnerability. So I suppose everyone had to do something about it. And the last one, which is the remote code exploit vulnerability in Apache ActiveMQ. Just a few hands. Nice. So these are all vulnerabilities that may exist in the ecosystem of your Java service. And if you look to the common vulnerability and exploit list or records, you can just easily look them up on, for example, cve.org. And you can see by this graph that the number of common vulnerabilities is rising and rising. So the last point in time is 2023. We're almost a year further. The line will be even higher this time. So it's important that we know that those common vulnerabilities will be exploited in the wild. So we have to find a way to protect our Java service against it. This year, Datadog released a report, the State of DevSecOps, which also goes a bit more into depth for your Java service. So within the report, you will find that they looked up a couple of production applications using different programming languages, using different frameworks, and they checked and saw that there were a couple of languages which were getting hit more often by common vulnerabilities. And you can maybe imagine that if you see this graph and Java is on the top, we all have to do something. Let's work together to make sure that next time for 2025, the report don't even show Java anymore. So this graph shows that the vulnerability in third package libraries in your Java service, which are actually actively being used in production. So what they did is they asked different companies to, for example, show their POM, and they checked and see whether or not there were vulnerabilities in the versions used by those companies. And this is actually the thing for production. So about 90% of the Java services in production do have one or more vulnerabilities in them. And it's not even that they are direct dependencies. Sometimes they can be indirect as well. So if you import one, you get a lot more, and somewhere down the line, there may be a service which has an uncommon vulnerability. A little bit about me. I'm Roald Nefs. I'm by no means a developer. I do some occasionally scripting. Been around for a few years. Been in some DevOps teams, but mainly focusing on the operation side. For the last year, I've been helping the Central Judicial Collection Agency in Leeuwarden to help them secure their environment even more. Within this CAB, I work in the first line of defense team, and we have one job, is to help the developers of our organization. We have one KPI we get to measure towards management to see whether or not we can actually decrease the number of vulnerabilities in our production environment. And how we do that is up to us. That's my day job. During night, I do all kinds of hardware hacking stuff. I see a couple of familiar faces, but they maybe have seen a talk, me explaining how to hack a car. We occasionally tell colleagues how to hack doorbells bought by in the Action. But that's something to show that security can actually be fun. And using examples of hardware, we can try and shift the same knowledge towards the software space. So today, I want to bring you along the software development lifecycle and check and see whether or not we can add in some extra things to make sure that we create more secure code. So I think you're all familiar with this. We start somewhere with defining the requirements for a new project. We end up creating an architect and design for the product. We actually develop code. Then hopefully you all test it. And if all tests pass, you deploy to production, and somebody has to maintain it. But in this life cycle, you can imagine that even though during the development phase you made sure that you had the latest and greatest Spring version installed, someone down the line a year later still has to update that one to make sure that when new vulnerabilities are found, we also update older software. So the big mind shift we have to take is that instead of approaching software development from a builder's perspective, we have to approach it from a breaker's perspective. Don't go for the happy flow. Take some time, take a couple of minutes a day to check and see whether you can actually break stuff. It's quite fun. You can actually look towards your code. Instead, try to find a test case tomorrow or the day after in one of your projects where you can actually, instead of testing for the known good, to test whether or not you can actually do something with weird input, for example, and see what happens in your application. If you're lucky and you're working in a big organization, or if your organization has a lot of budget, you can sometimes also request a pen test. So this pen test will often take place just before you release to production, or something happened in production and management suddenly realized that it is a good habit to test the rest of the application as well. But then you will come in contact with colleagues like me, which are going to take a week to hack your application. We build a nice report. We all hope it's green, but often we do make some red findings. And hopefully they discuss it with you to help you actually improve the code itself. But that's all. That's in the end of the software development lifecycle. We have already identified requirements. We already created the design. We started developing. We built our own tests. And then suddenly a pen tester appears and creates new exploits in your application. Wouldn't it be nice to see whether or not we can shift the security perspective towards the left, towards the start of the circle? So the other buzzword you will often come across is shift left. We'll discuss that a little bit more later during this talk. But the whole concept is that the earlier on in your software development lifecycle, you take some time for security, the less expensive it is for the company, because you have to realize that if you find during a pen test an exploit in your application, you have to redefine the requirement, you have to redesign the application, you have to rebuild something. So you have to take all those steps again in order to build a more secure application. So within the CUB, we help the development teams with that, with something called threat modeling. And threat modeling is something you can do already in the first piece of the part of the software development lifecycle. Then you may ask, what is threat modeling and how do we do it? Luckily, there are quite a lot of threat modeling methods. I won't bore you with that. The list is even longer. But if you want to look up something today, definitely check out one of those. Today, we will focus on a simple framework called a 4-question framework. And in this framework, we ask 4 questions only, and then we are already threat modeling. So the first step is, what are we actually working on? So with a group of colleagues, you first make sure that we are all talking about the same thing. Then, the most important question, at least for me, what can go wrong? How can we set this thing on fire? How can we make sure that it doesn't work in the end? You get to be creative. You you will see that the longer you do this, the more often you do this, you will get some new perspectives to help you the next time when you do a threat modeling session. Especially in the beginning, it can be quite hard, but I will also give you some tips today to get a little bit of ground knowledge to start off your threat modeling session to help you figure out what can actually go wrong during, within your application. It's nice to know how we set it on fire, but how are we actually going to prevent that someone else sets it on fire? Then you have already maybe a new user story to implement, or a new feature or a requirement for your project to make sure that it doesn't end up running the vulnerable code in production. And by the end, once you're finished with the whole development lifecycle, you also need to check whether or not you actually threat modeled the thing you had been building. Want we all know that during the software development lifecycle phase, we all get new requests, we build new features. So you will have to check somewhere that you actually threat modeled the thing you have built in the end. So as an example, we will be looking today to the OWASP Juice Shop, which is a web application you can all download. Please don't run it on your web server because it's an insecure web application. It's a juice shop. It's an example of a typical web shop where you can buy juices. And the whole thing is, it's packed with vulnerability. So one of the things we, for example, could look at during a threat modeling session is the whole application, but then you end up discussing with your whole team whole day to discuss all features within the application. So what we advise teams to do is, instead of looking towards the whole application, take an hour to look for a specific piece in your application. Great example can be the authentication part, the login portal. So take that one, go and sit together and ask the first question. What are we working on? And depending on the threat modeling method, they give you some advice in how you actually can do this step, how you can create a new diagram, but make sure that you don't create the architecture diagram beforehand, because you want to make sure that everyone in the room knows the same. If you have been the architect of an application, make sure that the junior who joins your threat modeling session also knows what we are talking about. So it's quite nice to actually take a whiteboard and just write it down. Today, for this talk, I did the betting. I just copied the earlier design. But the juice shop itself is built out of multiple components. It uses an Angular front end, Node.js on the back end, and it stores its data in a SQLite database. And apparently you can save some files, or there is some content on the back end as well. It uses OAuth for the authentication authorization part. And then the question for us is, what can go wrong? Does anyone have an idea what can go wrong with this application?
What can not go wrong?
I see a hand. Just shout. SQL injection. Nice one. Other ideas? Leaking too much information. Nice one. A third?
Malware in the content folder.
Malware in the content folder. Nice. So we already see that with a packed room, within a minute, we already have identified 3 possible things that can go wrong in our application. So then the question remains, what are we going to do about it? If we look towards the SQL injection, is any ideas what we can do to prevent the SQL injection in our application? Yeah? Input validation, great example. Prepared statements, that's a good one. But you see that you can, during such a session, together can come up with a couple of ideas how you can actually prevent those vulnerabilities. In the end, whenever you have built it, I hope that I can show you today how to test it yourself, but you can always ask a pen tester to take a look at your application and validate whether or not they can actually exploit SQL injection in your application. So you see that within a couple of minutes, we can already do a little bit of threat modeling. If you use the other frameworks I showed before, you get quite a lot of extra steps you can take. Some frameworks go into depth on how to document things about the threat modeling session itself. Note that you're then documenting the things where you're most vulnerable or maybe vulnerable in your application. Me as a pen tester also look for those documents on the internal wiki, because if the developers already told me where the application is most vulnerable, I will definitely have a look at those points during my pen test. So make sure that if you document such things, which you should do because you have to check in the end, that you store it somewhere private, that only the people who need to know this information get to see this information. Or use, if you are within a bigger company and use standard components, you can always build an example or demo application and show other teams how it could be done, how it could be documented. So we already did some threat modeling. Let's now take a closer look at the security testing itself, because it would be nice if we found something that we can actually test it ourselves. So if we take a look at the pen testing part, we started with a room packed of developers, and I hope to end with a room packed of developers and pen testers today. So the thing what we do during a pen test is that we use a simple method for finding threats. What we will actually do is gather information about the application, and it doesn't need to be in the application itself. I will always try and search for internal wikis, because they often document where we can find the database, or sometimes even note specific credentials for the admin, which is quite nice. Then if you have information about the application, which can either be documentation, or for example, the pom.xml, which displays which versions are used of dependencies, then you can identify vulnerabilities. So, for example, if you see that an older library is used in the application, you go towards cve.org and you actually look whether or not there are known exploits for the older library. And if you get very skilled at this, you can even find new exploits which haven't been seen before. There's a whole scene of pen testers which by night try and spend some hours to actually help companies find new vulnerabilities before the bad guys do so. So the moment you identify the possible vulnerability, you're going to analyze and verify whether it's actually exploitable in the application. The fact that you're using an older library doesn't mean that we can exploit the vulnerability itself. Sometimes it requires a couple of other requirements before it becomes exploitable. I will show you an example of that later today. The thing is, it's one thing to state what is wrong, but the pen tester also tries to help you a little bit to provide a recommendation on how to mitigate the vulnerability. An easy one is just don't use the library anymore, for example, but sometimes you need it to actually provide some features or to make sure that the program still works. So then we can, for example, help you use things on the platform layer. Maybe recommend to use a web application firewall, for example. In the end, we build a report, the thing everyone hates, the pen test report, which hopefully will get green next year. But unfortunately, we do often find things. Even we have quite a lot of skilled developers within our organization ourselves. So let's take an example. I tried to develop a Java application myself last week, so I ended up with this totally not suspicious web application, which nicely states the version of Spring Boot. I hope you all see that it's quite an older version, which looks vulnerable, right? So if you would have spent the time to look up those common vulnerabilities, we would have seen that there are actually exploits available for this specific Spring Boot in combination with other dependencies. A great resource next to cve.org is exploitdb. It's one thing to have a common vulnerability. You can go a level deeper looking for exploits on how to actually use the vulnerability to gain access to the system, for example. And you have a whole open database for such exploits. You can just download and use yourself. But you as a developer have the same opportunity. A nice thing within the Dutch government, we also have an organization called the National Cybersecurity Centrum, which reports which gives out some security advisory as well. They are open to the public, so definitely take a picture of this screen as well, because it often shows things we use in production as well for non-government organizations. But the moment they give out an advisory and they see that it is related, for example, to CUB, they will give us a call so that we can immediately take action. So as we saw from our totally not suspicious web app, it uses an older version of Spring. And in the beginning, I already hinted that there is a vulnerability for this one. Spring for Shell. So let's take a look at that. If we look it up on cv.org, we will find a specific identifier for this. It's an older vulnerability from 2022, which gives remote code execution on the environment where the application is running. So it allows the hacker to exploit the vulnerability and actually run code on the server running this application. So you can imagine if we can access the server, we can also access, for example, the configuration file in which we store the database credentials. Or we can install malware on it, use it to ransomware the organization. It was identified in March, but it was leaked before the Spring team was able to release a patch. So it was being exploited before there was a new version available, and information was actively shared among the hackers community. And some did good things by actually checking during weekends whether or not their own organization was vulnerable for this and helped them mitigate it before a bad actor exploited it. But it has been exploited in the wild. So with those kinds of vulnerabilities, you have some vulnerabilities which are quite easy to exploit. You will see that there are running scanners on the internet looking for specific web applications using specific dependencies, so they can actually exploit them. So the vulnerability itself affects the Spring framework, but it has a couple of requirements. It doesn't affect every Spring framework application. So some of the requirements for Spring for Shell is you at least need JDK 9 or higher. Your application has to run on Apache Tomcat as a servlet container. You have to have the application package as a WAR. You need a couple of other subdependencies like Spring Web MVC, and it affects specific Spring versions. The thing to note here is that the moment it was leaked and this information was available for you, there wasn't a newer version available at that time. So the only thing you know is you might be vulnerable to this exploit. There's no way to update yet. And of course, older unsupported versions may also be vulnerable for this. But what is the impact? What if a bad actor exploited this Spring for Shell in your application? Then he would get arbitrary code execution in the environment in which your application runs. So let's go to a web app. And I'm using Docker in this case on my local environment just to run an exploit, which is quite nice because you can actually play along and share this with colleagues as well to show them how they can actually exploit such a vulnerability. So if we go to our totally not suspicious web app, it should still work. And the only thing it does is I can send a message and it displays the message. And it obviously showed that I'm using the older version. But there was an exploit available for this, so I already downloaded it beforehand. And I can show the easy one, the smaller one. which is just one single curl command. So we make one post request towards our web server, towards your application, and then we can already insert some text. So in this case, the exploit would insert hello JFile via this vulnerability. The thing what is happening under the hood is that the components used are the framework maps your input data in a plain old Java object, and you expect a message. So I expect only a message data to appear from the form, but you can also give other classes. And what a hacker ends up doing is there's someone who had write an exploit which consists of a couple of components to write some dynamic code which allows you to create a new file on the web server itself, which you can then request again and provide additional commands to run on this environment, which is in this case the proof of concept written in Python, because the exploit was being released in Python on ExploitDB. It's just a small script you can easily find online. And it even comes out of the box with a nice help command. So we have to provide this proof of concept script a location, the URL of a web application, the file. So that's the file it's going to try to place on the Tomcat server itself, which we can then access via the browser to add additional parameters to run a command on the server itself. So in this example, the application is running on localhost port 8080, and we are going to create a file named jfile. It takes some time, and it prompts us with a nice log output that the shell should be available at this URL. And there we have it. So the nice thing is, what the proof of concept is doing is that it actually allows us to input a command, a Linux command, to run within the container. So I can now change this. For example, I can do who am I? Root. I can also look up things on the web server itself, or on the server itself, like see which other users are available, and so on and so on. So you can see that within a couple of minutes, we all were able to exploit this vulnerability and get access to the server and do all kinds of bad things. Obviously, the way to fix this is to now update your environment. You can find some nice information about this vulnerability itself on the Spring website, which also provides some extra steps. If you still need the older version, it also provides some information how to mitigate this with even older versions. So then we will go back to the thing we actually threat modeled today, the Juice Shop. It's a web application you can also run locally. So I already opened that, but make sure I close the Spring for Shell one. Let's see if it's still working. Yes. Make it a little bit smaller. So this is our amazing Juice Shop. We can click around, look for products. So as a hacker, what I will normally do is I will take some time to just see what the website should normally do, and I will take notes. Things I look for is some extra information. So if I go to this website and I click on a couple of things, you see we have additional links. There's some type of pricing available. We can write a review, which is an input field. Always nice to do something with. But for example, on the apple juice one, we also see that there's a review. And in the review, we see who created the review, admin at Juice Shop, which is nice because I suppose the admin also has an account on this web shop. And the thing we are all looking for is to gain the admin privileges on such a web shop, because then we can change prices, create our own products, do something else with the web shop. And if you keep looking, you will see other things. You can sometimes see which versions are being used. You can check other components. A nice one as well is like the search field is also a field where you can input stuff. It's always nice to see what happens if you look for normal stuff, banana, then it finds something. Then what a nice thing to do is just input random things, see what happens, and so on. And normally sometimes you get an error and then you know there's something wrong. You may be familiar with the web browser console, which is a nice way to start out. So you can open the console and the network tab, and every time you do things in the web application, new things should appear. It's a live demo, so let's hope so. Oh, I actually logged in as admin. Let's not do that. But you see that things pop up. We can actually see search queries coming by. And the nice thing is you can see the web headers used. You can see the payload which is sent towards the application. You can see the response by the server. It is, in this case, just JSON response. But the nice thing is you can also do this whenever you do other things. And then I have to find it. But this is, you already see this is a hard way. We have to locate the correct request in the web console, then we can go to the subtab. It's quite hard. So during a pen test, although I sometimes use this if I don't have any tools available, the thing I'm most often using is Burp Suite. And Burp Suite is at least the community edition, is a free tool you can download, and it includes a nice proxy. And whenever you go to the application, it will store all the requests and stores it in your history. The nice thing about this, if I make a request, for example, I have to do this in the correct browser, at least the browser which I started from, the application, banana. We should be able to find this request. In this case, the last one, to REST products / search. And the nice thing is we don't have to repeat it ourselves. We can send, there's actually a feature within Burp Suite called repeater. We can send it to the repeater, a new tab lights up. And from this repeater, we can repeat web calls. So I can just keep on doing the same thing. The nice thing is that I can also change things within the request itself. So I can look for an apple, and then I get the result for the apple. I can look for banana, and so on. So this is quite a nice tool to use yourself, because it not only helps you find vulnerability, it's also a nice way to debug APIs, for example. If you are lucky enough to have an employer who is willing to pay, you can even get the licensed version of Burp Suite, which comes with more goodies included. You can actually build automated things which will insert data for you. You can provide, for example, a password list to brute force applications. But in this case, we can keep it simple. If we go back to the juice shop, the end goal is, we saw that on the review page, there's a user called admin. In this case, for banana, there's a review by the user called Bender. So let's go back to the one with the admin. Let's copy the admin email address. Go to the login field. And a thing to try is just to brute force. So I can try, for example, common passwords like admin. Login, no, it doesn't work. password, doesn't work. What often will happen is that within all organizations, we use some kind of default passwords. That's also a nice one I try as well. The moment I start, I look around on, for example, Confluence, and I try to find out what our employees are using within our local development environment as their default password. So sometimes that may be a default 123, sometimes it's the name of the service itself, but those things you can often see that if that happens on one application, it will often happen throughout the whole organization. But the nice thing is we know from the threat modeling session that this application is using SQLite. Dus somewhere down the stream, something is creating a SQL statement to actually check and see whether admin is in the users table. The thing I know about as an experienced pen tester is that we can use SQL injection, which was one of the vulnerable things noted during the threat modeling session, that you can sometimes break or change the query. And one thing to look for is, like normally we place those variables in between quotes. So we can try to end the quote. So hope that this will get inserted in the query itself, and then write our own SQL statement. Or 1 equals 1, and then let's add a comment so that the rest of the script or the SQL statement gets ignored. And then suddenly we are logged in as admin. And obviously this is a vulnerable web application. This is built to be pen tested. This is built to as a tool to help you look and search for those vulnerabilities. If you have some time, definitely go to the scoreboard within the Jewel shop, because it includes quite a lot of challenges. And you can even get some hints which will redirect you to the official Jewel shop documentation, which doesn't give you the exact place where to find it, but it explains where you can find additional resources, for example, on how to do cross-site scripting. It gives some hints on where to find it, but doesn't exactly point you towards it. And in the end, you hope that you get the 100%. Each time you exploit one new vulnerability, there will be some emojis popping up telling you that you found another one. So you can see that with a little bit of threat modeling, we can identify threats. With a little bit of basic pen testing stuff, we can actually validate in our test environment whether or not we can exploit things. It's nice that we can look up common vulnerabilities and actually check and see whether or not exploits are available and test it ourselves, because that also helps you get an idea on what bad actors are doing. It gives you, lets you learn more about the Java language, lets you learn more about the dependencies you're using, and maybe we can see a pull request of you coming on helping us fix the Java ecosystem next year. But then the question remains, or most colleagues will ask me, is shift left security enough? Are we doing enough if we start doing threat modeling? And my answer obviously is no. The thing we try to explain is that there is, you try to shift left to fix security vulnerabilities in your environment, but you have to shift right to find them. You have to check your production environment to check and see what is running on production. You have to see in the production environment whether or not a hacker is inside. If you would only do it, the threat modeling part, if you would only fix things in your code, but the hacker is inside your environment and you don't do any monitoring, then bad things still can happen, because maybe the hacker doesn't come through your application, maybe it comes through the infrastructure part on your environment. So if you're interested in more security related things, a nice talk which is going to happen later today is by Boram, which is going to show the top OWASP projects beyond the OWASP top 10. I do expect that the Jewel shop will also come up in that. but that's definitely a recommender to help you gain a little bit of more knowledge or examples in which you can use during your threat modeling session. For example, the OWASP top 10 is the top 10 of issues which are being actively misused in your can be misused in your application, and that is great input for your threat modeling session. So then the question remains, do we have any questions for this talk? Yeah?
So at the start you mentioned like so many high percentage of companies have things with vulnerable libraries. But what often happens to us is there is a library and it has a CVE, but only if you use some feature that we don't
Exactly. Yeah. So the question was, or the statement is that we have this diagram in the beginning, which shows that we are running vulnerable dependencies in our environment. But that doesn't mean that we can actually exploit them in each and every application using such a dependency. And the thing we saw with the Spring for Shell one, you need to have a specific version of the dependency. You have to run it in Tomcat. It needs to be packaged as a var. So there are a couple of things you need to be in place in order for it to be exploitable. And then still, there can be other things within your environment that prevent hackers from coming in. If you never connect the servers towards the internet, no one from the internet is going to get access to it. So you can do other mitigating things. The thing to know is someone has to check whether or not you're vulnerable. So a nice way is whenever a vulnerability pops up is to go to the security team and say, in this case, we're not packaging this as a var, so we are not vulnerable in this case. Although we are using this version, someone has to check whether or not it can be exploited at that moment of time. The thing to note is that sometimes those vulnerabilities will be updated as well. We find new information during further investigation. So on day one, you might think you're not vulnerable, but down the line, another hacker found another way to exploit the same thing in a different setup. So someone has to check, and whether that's you as a developer or the pen tester helping you secure your application, someone has to figure out whether or not you're exploitable. And besides those vulnerabilities in the dependencies, maybe you write some code which includes a vulnerability itself, and it will not be listed on cve.org because you're the one who is the author of this code. But also in that case, someone has to check whether or not it can be exploited in other services which use the same practices within the organization. Other questions? Yeah?
You are an actual pen tester internally, so you only pen test your own company, or do you also pen test other companies?
Yeah, so I'm officially a consultant, so I do also take gigs outside of the Dutch government, but within CEB. When I started with my job as security specialist, we didn't even do pen tests. We asked another company to do pen tests, but we somehow went rogue, and we just advertised that we could do it ourselves as well, to actually, together with the DevOps teams, try and figure out where we are vulnerable. The fact that our infrastructure is built up of a couple of applications which are running on the outside. A nice one, for example, is ceb.nl, which is our public website. That's one of the services running on the outside, but we have a couple of 100 services running internally, which use the same components, which use the same Java stack for all of them. And by pen testing a couple of them, we were able to quickly identify vulnerabilities which were coming across our whole environment. And then, during threat modeling sessions, during further session analysis with architects, we were able to help those DevOps teams improve their code, not by one application at a time, but by doing that by 30, 40 teams for 5 or 6 applications which are being maintained by each team. So we have quite a lot of impact. We don't mandate internal pen tests yet, but we do have quite a big backlog of people actually requesting pen tests from us. Because we are not only giving them the report, we actually spend more time solving those issues together with them. We have one job, making CEB a lot more secure.
Yeah, we get pen tests a lot. We always get the
Yeah.
document I just sent back with, we've all considered this stuff, it's not a problem.
Yeah.
So it's annoying to me, but that sounds fine.
Yeah. One last question.
Do you have a recommendation for any plugins that are good for static code analysis to find bugs before they go out to?
Yeah, so any tips for static code analysis? Depends. There are a lot of free open source ones which are quite good. Definitely try and look and see whether or not they can fit into your CI/CD pipeline. I know, for example, if you're running or hosting things on GitHub, there are some default ones. Within bigger organizations, example for within the CUB, although I would like to prefer to add quite a lot of tools, we have to think about whether or not it fits our application stack. We can run a static code analyzer for Python, but most of the teams are using Java in this case. So we are, for example, currently creating a proof of concept with SamGraph, but also trying to see whether or not it has the same results as other tools. And the nice thing is that during a pen test, I'm free to get an open source tool to test it and to see whether or not it gets the same result as me. And most often it finds things I was not able to do during the pen test. Okay, then I would like to thank you all. If you have any further questions, I will be standing for a short time at the Dutch government booth, and otherwise you can find me around the conference. Thank you all.